Algebra Unit 6, Lesson 6, Notes 8, Systems of Equations Applications, Day 1. So what we're going to do here is we are going to take our knowledge from solving systems of equations and apply them. Okay, so take all the skills we've learned and put them into real-world situations or real-world problems. So letter A, we're starting off pretty basic. Is negative 2, 5 the solution to the system 2x plus y equals 1 and y equals negative x plus 3? So negative 2, 5 is a solution in the form of x comma y, meaning x equals negative 2 and y equals 5. So all we're going to do here is plug in negative 2 for x and 5 for y into both equations and see if it works. The first equation, we have 2x plus y equals 1. X is negative 2, y is 5. 2 times negative 2 is 4. Bring down everything else. And negative 4 plus 5 is 1. So it works for that equation. But it has to work for both. Y equals negative x plus 3. Y equals negative 2 plus 3. And actually, I need to replace y as well with 5. 5 equals negative 2 is positive 2. And positive 2 plus 3 is 5. So yes, this is a solution. Or the solution. And with that, you can do letter B. I'm going to jump to D. In the following, consider two linear equations. One is represented by a graph, and the other is represented by a table of values. Find the solution to the system of the two equations. Now on the left, it's already graphed, which is perfect. On the right, we're going to try and graph whatever we can here. So negative 2, 11, I cannot graph. 0, 5, I can definitely graph. That's up here. 3, negative 4, I can definitely graph. That's down here. So what I'm going to do is I'm going to go ahead and connect those dots and draw a line. I'm going to do the best I can. I'm going to have to move it, I think. Okay, and it looks like it intersects right here, which is at the ordered pair 1, 2. Another way you could do this, you can figure out the slope of the table. So here the change in y is minus 6, the change in x is plus 2, negative 6 over 2 means the slope is negative 3. So from the point up here on the top, we could go down 3, right 1, down 3, right 1, down 3, right 1, and I can still see that the ordered pair 1, 2 works out. Go ahead and try C on your own. Now for the rest of these problems, they're all each a little unique, so I'm going to go ahead and do all of them with you. Make sure you're paying close attention. They are different, and it will help you do your homework when you get to it. Letter E. Andy's cab service charges a $6 fee plus 50 cents per mile. His twin brother Randy starts a rival business where he charges 80 cents per mile but does not charge a fee. Write a cost equation for each cab service in terms of the number of miles. Now you can just use y and x if you want. However, I'm going to do something a little different. I'm going to call Andy's cab service A of M, where M represents our miles. So A of M equals, he charges $6 plus 50 cents per mile, so 0.5 miles. Randy, I'm going to name R of M. He just charges 80 cents per mile, so 0.8 M. Now I have to graph these, and graphing decimals can be a little bit confusing. So I'm actually going to change these to fractions. 0.5 is 1 over 2, so that'll tell me my slope for that. And 0.8 is 8 over 10, which reduces to 4 over 5. So these are our slopes, which will help when we graph. Okay, I have the distance on the bottom, which is measured in miles. And I have the cost on the y-axis, which is measured in dollars. And I'm going to go ahead and count each block as 1, so there's no need to label it, but you can if you would like to. I'm going to zoom in here to help me graph. Let's start with Andy. Andy charges a fee of $6. That means the y-intercept is $6. 1, 2, 3, 4, 5, 6. Plot a point. And he charges 50 cents per mile, or as we figured out, 1 over 2. So up 1, right 2. Go ahead and plot. Up 1, right 2. Keep going. Again, my graphs are going to be slightly off. It's hard to graph on this program. And we're going to draw a line. And it should have an arrow on the end. And this one was Andy. So because I distinguished between the two with A of M and R of M, I don't have to write the whole thing out. I can just write A of M. Okay, let's look at Randy. Randy starts off at 0. He doesn't charge a flat fee. And he goes up 0.8 miles, so it's 4 over 5 as we figured out. So go ahead and plot those. And draw your line. Just going to adjust mine a little. There we go. And this is Randy. If it's too confusing labeling at the ends, you can always label on the lines. So you could say R of M here and A of M here. Or you can color code, doesn't matter. On a Regents exam, you don't really have different colors, so whatever works best for you, as long as you label. Okay, so they are graphed. Now let's answer these questions. For what trip distances should a customer use Andy's cab service? For what trip distances should a customer use Randy's cab service? Justify your answer algebraically and show the location of the solution on the graph. So to figure out which one we should use, we need to figure out which one, or at what distance they're equal. So I'm going to set them equal to each other. 6 plus 0.5 m equals 0.8 m. And let's go ahead and solve. Subtract 0.5 m. 6 equals 0.3 m. Divide by 0.3. And we get 20 equals m. So I know at 20 miles they're the same. And if you look at your graph, that is accurate. At 20 miles, it looks like, counting up, they pay $16. Let's fix that a little bit. $16. Okay. So I want to use the cheaper service. So it looks like Randy's line, which is the red line, is cheaper than Andy's up to 20 miles. Then it's more expensive. And also, Andy's is cheaper after 20 miles. So that's what we're going to write. I am going to type it, though. So we want to use Andy's. Oops. after 20 miles. Or I should say more than 20 miles. And we want to use Randy's less than 20 miles. Let's move on to F. Find two numbers such that the sum of the first and 3 times the second is 5, and the sum of the second and twice the first is 8. So I'm going to say, let x equal my first number, and let y equal the second number. Okay, so the sum of the first and 3 times the second is 5. That's one equation. And the sum of the second, which I'm going to line up here, and twice the first is 8. We have just written a system of equations, so now let's solve. I prefer to use the elimination method, but you can use whichever method you prefer. I'll get rid of the x's here. I'm going to multiply this top equation by -2. And I'm going to move the problem up here. So I have -2x minus 6y equals -10. And the other equation, just bring over 2x plus y equals 8. Go ahead and add them. I have -5y equals -2. Divide by -5. Y equals 0.4. Now that I have the second number, let's plug in to find the first. X plus 3y equals 5. X plus 3 times 0.4 equals 5. X plus 1.2 equals 5. Subtract 1.2. X equals 3.8. Now this isn't really asking for an ordered pair. In most of these problems, you would just box your two answers and not write them as an ordered pair. What I'm going to do for this page, G, H, and I, I'm going to help you set them up, and then you are going to continue and solve them. So letter G, Pam has 2 part-time jobs. At one job, she works as a cashier and earns $8 per hour. At the second job, she works as a tutor and makes $12 per hour. One week, she worked 30 hours and made $268. How many hours did she spend at each job? So we are finding the hours at each job. So let's say let x equal hours cashing. So as a cashier. And let y equal number of hours tutoring. Okay. We are talking about when you're solving problems like these and you're finding 2 unknowns, 2 variables, you need to figure out what 2 things you're talking about. In this instance, we have our hours, which we are finding, and we have money. So we need an equation that reflects the number of hours, and we need an equation that reflects the amount of money. So in total with hours, she worked X hours of cashing, and she worked Y hours of tutoring, and altogether, I know she worked 30 hours. So I take my X hours, my Y hours, add them together, and I get a total of 30. That's one equation. I took care of the hours. Now let's talk about the money. She earns $8 cashing. She earns $12 tutoring. And altogether, I know she made $268. So again, one with hours, one with money. There are your 2 equations. And go ahead and solve that system on your own. When you solve this, I'll let you know what the answer is. You should get 23 hours cashing and 7 hours tutoring. So if you did not get that, see if you can go back and find your mistake. Letter H. A chemist has 2 solutions. a 50% methane solution, and an 80% methane solution. He wants 100 milliliters of a 70% methane solution. How many milliliters of each solution does he need to mix? So we want to know the milliliters of each solution. So let's name those X and Y. Let X equal milliliters of 50% solution. And let Y equal milliliters of 80% solution. Okay. So again, we're talking about two things. We want to know quantity, the milliliters, and we also have a percentage. Remember, when we're calculating with percentages, we do need to change these to decimals. Okay, so let's talk about just the quantity. I know I want X milliliters of the 50% plus Y milliliters of the 80%, and I want that to total 100 milliliters. So that's the quantity equation. Now let's talk about the percentage. I have 50% methane solution plus 80% methane solution. Remember, we're changing our percents to decimals. And I have 70% of the total. Now the total is 100, so really 70% of 100. If you notice, all we did here is we took our original equation in red, X plus Y equals 100. We still wrote it, but just multiplied each of them by the percentages. Okay, so one equation represents the quantity, the other equation represents the percentages. Go ahead and solve that equation, and you should actually end up with some repeating decimals here, so make sure you keep them either as improper or mixed numbers, what they really make sense when you're looking at it. So for this one, you should have gotten 33 1/3 milliliters of the 50% and 66 2/3 milliliters of the 80%. If you came close and did not get the correct answer, you probably rounded somewhere. Do not round. You have a graphing calculator. It will calculate everything for you. Keep them as impropers if you must, okay? Letter I. A store sells Brazilian coffee for $10 per pound and Colombian coffee for $14 per pound. If they decide to make a 150-pound blend of the two and sell it for $11 per pound, how much of each type of coffee should be used? Okay, so we want to know how much of each type of coffee. So we want to know how many pounds of Brazilian and how many pounds of Colombian. So let X equal pounds of Brazilian coffee. I'm going to abbreviate here. And let Y equal pounds of Colombian coffee. Okay, so again, we have quantity and cost. We have X pounds of Brazilian plus Y pounds of Colombian, and we want a total of 150 pounds. Letter I is similar to letter H in that we're kind of keeping the same equation for our second one, but we're adding in the price. So the price is $10 per pound for the Brazilian plus $14 per pound for the Colombian, and it totals at $11 per pound for the mixture, which is 150. Those are your two equations. Go ahead and solve them any way you prefer. You should have wound up with 112.5 pounds of Brazilian and 37.5 pounds of Colombian. Again, if you didn't get these answers, go back and see where you made your mistake.